Hi, we're going to do an overview of the lab report that you'll create for the gravity simulation. You should see a folder that looks like this for our gravity simulation. Simply click on that. Inside that folder, you'll see our sample lab report. You can take a look at that to see how your lab should look. We will be turning in the signed data once you get that done in class. This is our lab report itself. It will give you instructions for the lab report. And I added down here some information on scientific notation if you need to review that, because we'll be using a lot of scientific notation in this. They're very, very small numbers. Here's our two questions that we hope to answer. What is the mathematical relationship between the force of gravity and the distance between two objects? The second question is, what is the mathematical relationship between the force of gravity and the mass of the two objects? Now, I added some mathematical models here, and we want to answer these two when we talk about the mathematical relationship. Is that mathematical relationship a linear relationship, a quadratic relationship, or an exponential relationship? We're going to create graphs and see if we can tell which one of these it is. So here's our simulation. We have two masses, M1 and M2. We are given the force of gravity of M1 by M2 right up here, and the corresponding force on M2 by the gravity of M1 here. Notice that they're the same. Notice that they're very, very, very small numbers. So what we're going to do is we're going to come down here and we're going to put those in scientific notation to make that a little bit easier for ourselves. So what we can do is we can take these masses, we can move them back and forth. We can measure between the centers of the two in meters here. And we can change the mass of each one down here. Here's our lab report template. We've used these before. The purpose or the question is written in there for you. You'll go up here and make a copy of this, and that way you can do whatever you want to with it. If you mess it up, don't worry. You can always come back here and make a new copy. Our part 2, the theoretical, we're going to simply describe Newton's law of universal gravitation. Go back to the video notes on gravitation to fill out this part here. With the equations, there'll be just one equation for that. And then tell us how the concepts relate to this lab. The experimental will be a little bit different on this one because it is a simulation. The list of materials will simply be the simulation. And again, we're going to write a short paragraph explaining what you did. Simply use a screenshot here. You don't need to photograph, so the reader knows what you did. For our analysis section, we'll need two graphs. The first graph will be force of gravity on the vertical axis and the mass of one of the spheres on the horizontal. The other graph will be, again, the force of gravity on the vertical axis, and then the horizontal axis will be the distance. Now there's a chance for some bonus points here where you can do a third graph that has the force of gravity again on the vertical axis and then the square of the distance on the horizontal. And finally, our conclusion, you're going to make a claim. What kind of relationship do these two have? Are they linear, quadratic, or exponential? The evidence, you'll describe how your data changes as you, say, make the distance different or make one of the masses different. Give the ranges that you used. And then finally, your reasoning, explain how the physics concepts link your evidence to your claim. Tell us again briefly about Newton's law of universal gravitation and how your data fits with that. So for your two data tables for your two graphs, you'll need a data table that has the force in newtons and the distance, which can be either r or d in meters here. And you'll need about 5 data points. The other graph will be measuring the force of gravity in newtons, and let's say the mass, we'll just change mass 1. Now remember, when we're doing this, we want to keep everything the same except for what we are changing. All right, good luck on your lab, and we'll see you in class and see what questions you come up with.